instrumentation amplifiers using operational amplifiers. These instrumentation amplifiers are very useful in amplifying the difference mode signal and rejecting the common mode signal. So they find numerous uses where we do remote sensing. We want to find out very small signals which ride over the common mode signal. So it says it is a differential voltage gain device that amplifies the difference between the voltages existing at its two input terminals. The main purpose of an instrumentation amplifier is to amplify small signals that are riding a large common mode signal. यानी common mode signal के साथ मिल के अगर एक छोटा सा difference mode signal आ रहा है तो instrumentation amplifiers का काम है कि उस छोटे difference signal को amplify करे और common mode को reject करे. So we know, इसका मतलब क्या है, इस device के पास बहुत high CMRR होना है. What was CMRR? Common mode rejection ratio. Common mode rejection ratio. तो ये common mode rejection ratio इसका, so that is nothing but AD by AC, difference gain divided by common mode gain. तो जितना ये gain कम होगा ये gain ज़्यादा होगा, definitely CMRR will be higher. So these devices, they have a very high common mode rejection ratio. So here the voltage gain is set with an external resistor. These amplifiers are used in environments with high common mode noise such as data acquisition systems where remote sensing of input variables is required. The importance of this device lies in the fact that it has a high differential voltage gain and a low common mode gain. It also has a high CMRR, low drift, low noise, very high input impedance. Operational amplifier है तो very high input impedance होगा ही, and very high open loop gain as well. तो open loop gain भी high होगा operational amplifier use कर रहा. They are preferred over difference amplifiers because in difference amplifiers there is common mode gain. होता क्या है, if the resistance are equal, say R1 and R3 are equal and R2 or R4 varies even by 1%, तो there will be a common mode gain. तो ये common mode gain को हमको हटाना है, we need to discard this. So that is why difference amplifier के जगह पे instrumentation amplifier use किया जाता है, because you must have said कि why not difference amplifier भी तो वही करता. So but they एक high precision resistances का ज़रूरत पड़ता है, थोड़ा सा भी difference होने से common mode signal will appear across the output. So for these very high precision, for these purposes, very high precision resistors are required, and hence they come in form of an IC chip where only one resistor can be connected externally. अब एक ही resistor लगा रहे हैं तो उसमें दोनों के साथ match करना नहीं करने में कोई ज़रूरत नहीं है. तो there is only a place where you can connect one external resistor. So let us see the diagram of the instrumentation amplifier. So this is the diagram of instrumentation amplifier. You can see there are two amplifiers, say 1 and 2 left hand side and another say 3 at the right hand side. Left hand side amplifier stage is called the buffer stage, और उसके बाद वाला जो portion, it is nothing but our difference amplifier. ये circuit तो हम जानते ही हैं, this circuit is nothing but the circuit of a difference amplifier. लेकिन कर क्या रहा है, ये जो बफर स्टेज है यही कॉमन मोड सिग्नल को हटा दे रहा है और सिर्फ डिफरेंस मोड सिग्नल जहां यहां पे आएगा अक्रॉस दीज टू पॉइंट्स, अक्रॉस दिस पॉइंट एंड दिस पॉइंट, दिस विल एम्पलीफाई द डिफरेंस सिग्नल. सो ये पार्ट जो है, दिस पार्ट इज नथिंग बट द पार्ट ऑफ डिफरेंस एम्पलीफायर एंड दिस पार्ट इज द बफर स्टेज वेयर VB and VA, this is the input points. These are connected to the non-inverting terminal of the operational amplifier. You can see the inverted end is connected to this loop. There is a feedback loop. ये VB के लिए the feedback loop is through R5 and VA के लिए the feedback loop is through R6. यहाँ से एक feedback loop है और ये दोनों point के बीच में this is the external resistor RG. बाकी हर एक रजिस्टर जो है this one, this one, this one, this one, this one, this one, all these resistances are internally connected inside the chip. We don't have to do anything. We can only connect this RG from outside. इसी को हम सिर्फ लगा सकते हैं and this is, we call it RG इसको यूज करके ही I can reject different types of common mode signal. Let us see how do we do it. Let these points be, this is point P, this point is point Q, this point is point R, and this point is point, this point is point S. So these are the points. I have named these V dash B, V dash B. This point is V dash A. This is VB, this is VA. Why? Let me tell you. We will tell you this. Okay. So now, first what we do is, we know that the output of the difference amplifier, EA output, this output is given by VO, that is equal to minus R2 by R1 multiplied by VB dash minus VA dash. VB dash, because इस जगह पे what is the input, that is nothing but VB dash. इस जगह पे what is the input, VA dash or V dash A, whatever. So यहाँ पे इसका जो output है, it is nothing but minus R2 by R1 V dash B minus V dash A. This we know very well. Now let us consider that R2 by R1, it is not let us consider, we assume here that R2 by R1 is equal to R4 by R3, right? So that means this is equal to R2, this is equal to R3, R1. So they are the same. So we obtain this formula V naught equal to minus R2 by R1 V dash B by V dash when R2 by R1 is equal to R4 by R3. Then we arrive at this formula. We know this again by our semester 4 or semester 3 concepts. So that is there. Now, due to presence of feedback, we can use the concept of virtual ground. Virtual ground करने का मतलब क्या है? We say, you know, that यहाँ से due to very high input impedance, no current flows through this point. And if since no current flows this point, so what we can say that if this is at VB, this point will also be at VB. And since this point is connected to this part, so this point will be also at a potential equal to VB. Similarly, VA is there and nothing flows through this. Okay? Hence, what we can say is this point is also at VA, and that is why this is connected this way. So this point is also at VA. I hope you agree to this. We know this. We know these things. We have already seen in case of operational amplifier. So this point is VA, and this point is VB. Now, if I assume for the time being that VB is greater than VA. If VB is greater than VA, definitely there will be a current which will be flowing through this resistor from here to here. So there is a current flowing because VB is greater than VA. So the same current I will also, that means VB अगर greater than VA है, तो Q से R तक there is a current flowing. The same current will flow from P to S because operational amplifier में तो कोई current flow ही नहीं करता. तो अगर यहाँ से यहाँ तक वही current flow करेगा तो same current I will flow from P to S because इधर तो कोई current जाना नहीं है, no current flows within the operational amplifier. So what we say is when VB is greater than VA, so then what happens is there will be a current flowing from Q to R, and the same current will be flowing from P to S, right? Because there is no current flowing inside the operational amplifier. So now, what we do is, we have these ideas, and that is how I said why we can write these points, why we can write them as VB and VA. इसको VB क्यों लिखा और इसको VA क्यों लिखा? Now we understand that. So then, अब हम लोग अगर ये लिखना चाहे then V dash B minus V dash A, this will be nothing but I multiplied by R5 plus RG plus R6. I hope you will agree to this. V dash B minus V dash A equal to I multiplied by I5 plus RG plus R6. If we assume that R5 is equal to R6, so then VB dash minus VA dash, this is equal to I into RG plus 2R5 or 2R6, whatever you write. So we get this value. Now, say we write this, we give this equation number 1 और इस equation को हम बोलते हैं equation number 2. Okay. Also, between the point Q and R, between Q and R, हम क्या लिख सकते हैं? VB minus VA, this is equal to I multiplied by RG. तो I का वैल्यू हम निकाल सकते हैं. This I is nothing but equal to VB minus VA divided by RG. I can obtain this value of I. Let me call this equation number 3. Now, substituting the value of this equation, substituting this value in equation number 2, what we get is VB dash minus VA dash, that will be equal to VB minus VA by RG multiplied by RG plus 2R5. This can be written as equal to VB minus VA multiplied by 2R5 by RG plus 1. 2R5 by RG minus 1. Plus 1. So we obtain the value V dash B minus V dash A. If I substitute this value for the output V naught, this is nothing but R2 by R1 V dash B minus V dash. ये वैल्यू हमको मिल रहा है. So if I remove this, इसके जगह पे I substitute the value V dash B by minus V dash A का वैल्यू को अगर हम substitute कर दें, so we get here V naught, this is equal to minus R2 by R1 multiplied by VB minus VA multiplied by 2R5 by RG plus 1. This is what we obtain as the expression for output. This is the expression for output. Now, यहाँ से हमको कॉमन मोड सिग्नल के बारे में तो कुछ पता नहीं लग रहा है. This is the signal, but you can see VB minus VA. This term is very, very important. Now, if a common mode signal VM appears across VB and VA, अब जो है, now you note down this equation, minus R2 by R1, VB minus VA to R5 by RG plus 1. I am removing this. Now if I say, हमारा काम actually क्या था? We would need to remove the common mode signal and difference and amplify the different signal. तो अगर एक common mode signal यहाँ पे आ रहा है, इस दोनों के बीच में एक common mode signal अगर appear हो रहा है, and that common mode signal is equal to VM, यानी VB में भी VM आ रहा है और यहाँ पे भी VM आ रहा है, तो क्या होगा? This VM will be available here also. So if that Vm is available here, so this will be equal to Vm because of this feedback system. You know, nothing flows through this if Vm is available, so Vm will be here and this Vm is available, and this Va will also be equal to Vm because ये Vm है तो ये Vm होगा, ये Vm है तो यहाँ से connected है, this is Vm. So if a common mode signal Vm appears across Vb and Va, then point Q and point R will be also at Vm. दोनों Vm में रह गया. And similarly, no current flows between point Q and point R. दोनों Vm में है तो कोई करंट फ्लो करने का तो कोई चांस ही नहीं होता है, तो नथिंग विल फ्लो थ्रू पॉइंट Q एंड पॉइंट R. सो सिमिलरली यही करंट अगर सब में फ्लो करना था, सो पॉइंट P एंड पॉइंट S विल ऑल्सो बी एट Vm. तो इसी एनालॉजी से जो हम तभी से बना रहे हैं, तो हो क्या गया, ये पॉइंट है नो करंट फ्लोज, तो ये Vb है तो यहाँ पे भी ये Vm है तो यहाँ पे भी ये Vm हो जाएगा, और यहाँ पे भी जो है ये Vm हो जाएगा because no current is flowing in this circuit. So points P and S will also be at Vm. तो इससे क्या हुआ, ये Vm और Vm है, दोनों Vm अगर इस सिग्नल पे कर डाल दिया जाए, so that part will be automatically removed because V0 is Vb minus Va. तो वहां से जो कॉमन मोड सिग्नल है that will be gone. कॉमन मोड वाला पार्ट जो है इन द डिफरेंस एम्पलीफायर स्टेज इट विल नॉट अपीयर. तो हमारे पास क्या मिलेगा, सो द टू एम्पलीफायर्स विल जस्ट सर्व एज अ बफर एम्पलीफायर. यानी ये क्या किया, कॉमन मोड सिग्नल को यहाँ ले आया, इसको डिफरेंस मोड में देंगे, डिफरेंस सिग्नल में तो खाली डिफरेंस को ही एम्पलीफाई करता है, कॉमन को कैंसिल करता है. तो दोनों में Vm है तो आउटपुट में कॉमन मोड नहीं रहेगा, इट विल हैव ओनली द डिफरेंस सिग्नल and it will amplify the different signal. यानी AC का वैल्यू बहुत घट गया and AD is very high, so that means the CMRR will be very high. So what happened is this one just works as a buffer stage, और इस buffer stage के बाद what happens is जिसके कारण जो सिग्नल हमको मिल रहा है that is nothing but the different signal only, and that different signal gives me the amplified output. तो इसका इंस्ट्रूमेंटेशन एम्पलीफायर का यही काम हुआ कि it amplifies the different signal rejecting the common mode signal. यानी कहने का मतलब क्या है, you know, if there is this is a large signal, और इसके साथ जो है ना डिफरेंस सिग्नल सब जा रहा है, very small difference signal, they are riding on this large signal, इस तरह से जा रहा है, right? तो यहाँ पे भी कुछ ऐसा ही है, in this one also it is kind of same. तो यहाँ पे भी कुछ जा रहा है, कॉमन मोड सिग्नल है दोनों में, तो द डिफरेंट सिग्नल इज पासिंग. ठीक है, मे नॉट बी द वेरी एक्यूरेट डायग्राम, बट इस तरह से जा रहा है. So across the output what we get is we get the amplified difference mode signal only, amplified difference mode signal. This is the output of the instrumentation amplifier. That's it in this chapter.